Question 15, and there's some very strange context in this question. A chef needs to use an oven to boil some water. Most people use a kettle. However, for some reason anyway, the temperature must reach 100 degrees to boil, and here's our model. Initially, T0 is 200. Now, a quick scan of this question. Part A, we've got to substitute in 0 for time and work out what T is with T0 as 200. Then we've got to work out the temperature after 5 minutes, and then because we obviously don't get to 100 in 5 minutes, we've got to fiddle around and work out T0. So basically we're just working on this formula here and trying to solve some problems. So with ClassPad, I just nip off into old NumSolve and chuck the formula in here. We go down to the keyboard, go to my variables, and start off with a capital T for the temperature is equal to 200 minus 175. We need an E, so we'll pop up to here. E to the negative 0.07 T, I think it was the like. So we'll use a lowercase t for that one. And we're actually going to need to change this one in a second. So let's call this one capital I for the initial temperature. So here we go. The initial temperature for the first question is 200. The time is 0 and we want to solve for T. Done. The initial temperature is 25. Then for part B, what is the temperature of the water after 5 minutes? So then we'll change T to 5 and solve for T in 76.68. So there's another easy mark. This is like money for jam, isn't it, guys? Anyway, and then we actually want to get T to be 100 in 5 minutes. So now we'll change T to 100 and solve for what the initial temperature should be. Solve, and it's 223.32. So we'll put down one line of working there because it's a 2 marker, and then just come up with our solution for T0 out of that one. So that's okay. So carrying on into part D, we now have got to assume T0 is still 200, and we've got to work out the rate of increase in temperature. Now, just a note of caution, because f of t is not of the form AE to the kt as in the syllabus, we can't use our regular method of doing this and just saying that the rate of change is proportional to kt and come up with this answer, which would obviously be wrong. So we've actually got to differentiate our temperature function and sub in 5. So ClassPad may as well do the work for us. I'm just going to change I to actually 200, and to save typing this all out again, I'll just take a copy from here, head back into main and paste it in, tap execute, and then, oh, T must have a value, so I better edit, clear all variables, okay, and then tap on that one again. So, let's go back into standard mode, and third time lucky. Right, here we go. We've got the function. We now want to differentiate it. So shift 7 for me. But because it's with respect to T, I'm going to say the answer with respect to time. And I'll steal a little T from up here just to get that. So we're differentiating this. So here's our derivative, and then we simply need to sub into that one. So we want the answer given that T is equal to, so we'll steal the T from there this time, T is equal to 5. And this time we'll do it in decimal mode, because that's not going to look very pretty in exact mode. So there it is. It's increasing at 8.63 degrees centigrade per minute. And then finally, part E, what happens to the rate of change in temperature as time increases, for 3 marks. So basically we can start off by saying as time increases, the rate of change will decrease. And then how does this relate to the temperature of the water? So obviously we know that as T goes up, the rate of change here is going to be e to the negative. And as T increases, e to the negative is going to become very close to 0. So that's what we're saying here. As T tends to a large number, the rate of change tends to 0. And so that's backing up this from the differential equation here. And so the temperature of the water increases at a decreasing rate and will approach but never quite reach 200 on that one. So I'm guessing one of the 3 marks is for stating that the long-term temperature of this water is or the water in the oven will get close to but never quite reach 200 degrees.